The hidden cost of war: transport, maintenance, and supply. Part 1. The invisible backbone. War is often measured in battles won, territories claimed, and lives lost. History books celebrate the decisive charge, the brilliant flanking maneuver, the courageous last stand. Monuments commemorate soldiers who fell in combat. Museums display captured weapons and tattered battle flags. Yet behind every advancing army, every sustained campaign, and every strategic victory lies an invisible network that consumes more resources than the fighting itself. This network, unglamorous, technically complex, and absolutely essential, represents the true backbone of military power. For every soldier on the front line, there are dozens more engaged in the grueling work of moving supplies, repairing equipment, and maintaining the vast logistical apparatus that makes modern warfare possible. These individuals rarely fire a shot in anger. They drive trucks through hostile territory, repair tank transmissions under enemy artillery fire, manage supply depots in scorching deserts or freezing mountains, and coordinate the movement of millions of tons of material across oceans and continents. Their work determines whether armies eat, whether tanks move, whether aircraft fly. Without them, the most elite combat units become helpless refugees, stranded and starving behind enemy lines. The mathematics of war are unforgiving and often staggering in scale. An infantry division of 15,000 soldiers requires approximately 600 tons of supplies per day during active operations. This includes not just ammunition and fuel, but food, water, medical supplies, spare parts, batteries, communications equipment, and countless other necessities. A single armored division can consume over 300,000 gallons of fuel in a week of combat, enough to fill nearly 700 standard automobiles completely. During the 1991 Gulf War, coalition forces consumed 6.1 million meals per day. The bottled water requirement alone exceeded 1.3 million gallons daily in a theater where local water sources were scarce and potentially contaminated. These numbers represent not just material costs, but the hidden burden of transportation networks, storage facilities, maintenance crews, and security forces required to keep the war machine functioning. Each ton of supplies must be manufactured, packaged, transported multiple times, stored in climate-controlled facilities, protected from theft or sabotage, inventoried, distributed, and finally delivered to the point of use. The infrastructure required is immense. During World War II, the United States constructed over 600 military installations across the globe specifically for logistics operations. Many of these facilities were larger than major civilian airports or seaports. The supply chain extends backward from the front lines through an intricate web of dependencies. Combat units receive supplies from forward supply points, which are restocked from brigade support areas, which draw from division logistics nodes, which are supplied by corps-level depots, which receive shipments from theater distribution centers, which are fed by strategic airlift and sea lift from the homeland. Each link in this chain requires personnel, equipment, facilities, and coordination. A disruption anywhere in the system cascades forward, potentially paralyzing operations thousands of miles away. Throughout history, commanders have learned this lesson repeatedly, often at catastrophic cost. The annals of military failure are filled with armies that outran their supply lines, that assumed logistics would somehow take care of themselves, or that prioritized tactical brilliance over logistical sustainability. Napoleon's Grande Armée that invaded Russia in 1812 numbered over 600,000 men at the start of the campaign, the largest European military force ever assembled to that point. This massive force was supposed to overwhelm Russian resistance through sheer numbers and superior tactics. The reality proved devastatingly different. The vast Russian spaces swallowed Napoleon's supply system whole. Roads that existed on maps proved to be muddy tracks, impassable to heavily loaded wagons. Promised food supplies from conquered territories materialized far below expectations as Russian forces employed scorched earth tactics. The French army's horses, essential for moving artillery and supplies, died by the thousands from overwork, inadequate fodder, and disease. As the army advanced deeper into Russia, the supply lines stretched thinner and more vulnerable. The retreat from Moscow became a logistical apocalypse. Soldiers marched in temperatures that plunged to -40 degrees without adequate winter clothing because the supply wagons had been left behind or abandoned. Starvation became endemic as foraging parties found only burned villages and empty storehouses. Horses collapsed and were immediately butchered for food. Discipline disintegrated as men fought over scraps. Of the 600,000 men who entered Russia, fewer than 100,000 survived. Disease, exposure, and starvation killed more soldiers than all the battles combined. The lesson was clear. Armies don't just march on their stomachs, they march on wagon trains, supply depots, and the shoulders of thousands of unsung laborers. The American Civil War provided another brutal education in logistical reality. The Confederate Army, despite tactical brilliance and soldiers renowned for their fighting spirit, faced insurmountable logistical disadvantages. The South possessed limited industrial capacity, a railroad network one-third the size of the North's, and insufficient skilled workers to maintain what infrastructure existed. As the war progressed, Confederate soldiers increasingly fought barefoot, carried obsolete weapons, and survived on starvation rations, while Union forces benefited from an ever-expanding supply network. Union General William Tecumseh Sherman understood logistics with exceptional clarity. His march to the sea deliberately targeted not enemy armies, but logistical infrastructure supporting them. He destroyed railroads, burned supply depots, confiscated livestock, and demolished factories. Sherman recognized that destroying the South's ability to supply its armies would prove more decisive than defeating those armies in battle. His campaign demonstrated that logistics is not merely support for war, it is a primary target and weapon of war itself. World War I showcased logistics at an unprecedented scale. The Western Front, stretching from the English Channel to Switzerland, became a vast industrial enterprise. Artillery bombardments consumed shells at rates that would have been inconceivable in previous wars. The preliminary bombardment before the Battle of the Somme fired 1.7 million shells in 7 days. Supplying just the British sector required 50 trains per day carrying ammunition, food, equipment, and reinforcements. The French railway system operated over 2,000 military trains daily at the war's peak. Managing this supply flow required tens of thousands of logistics personnel, sophisticated scheduling systems, and purpose-built infrastructure, including hundreds of miles of narrow-gauge railways connecting frontline positions to main supply routes. The trenches themselves became permanent logistics installations. Each required constant resupply of ammunition, food, water, timber for shoring up walls, sandbags, barbed wire, duckboards to line muddy floors, and endless other materials. Medical supplies alone constituted a major logistics burden, as armies struggled to evacuate and treat casualties on an industrial scale. Hospitals, ambulances, medical supplies, and personnel consumed resources that rivaled combat operations. The transition to mechanized warfare in World War II multiplied logistics demands exponentially. Armies no longer moved at the pace of marching men and horse-drawn wagons. They raced across continents in tanks and trucks. But this mobility came at enormous cost. Mechanized forces consumed fuel and spare parts at prodigious rates. A single German panzer division required 30,000 gallons of fuel per day during active operations. The Wehrmacht's advance into the Soviet Union repeatedly stalled not because of enemy resistance, but because fuel trucks could not keep pace with the panzers. German tanks sat immobilized with empty fuel tanks, while Soviet forces regrouped and counterattacked. The lesson reverberates through every conflict since then. Speed and firepower mean nothing without the logistics to sustain them. An army is only as mobile as its supply chain allows. The most advanced weapons become useless without fuel, ammunition, and maintenance. Victory goes not necessarily to the side with better soldiers or superior tactics, but to the side that can sustain operations longer, supply its forces more effectively, and maintain equipment in working condition when it matters most. This reality transforms how we must understand military power. The visible elements of armed forces, the soldiers in formation, the tanks on parade, the aircraft screaming overhead, represent only the tip of an enormous iceberg. Beneath the surface lies the vast, complex, unglamorous infrastructure of logistics. Understanding this hidden dimension is essential to grasping not just how wars are fought, but why they are won or lost, what they truly cost, and how modern societies sustain organized violence across vast distances and extended time periods. The invisible backbone determines everything. Without it, armies starve, vehicles stop, weapons fall silent, and soldiers die not from enemy action, but from the collapse of the support systems that keep them alive and fighting. Recognition of this reality must inform every discussion of military capability, every decision about whether to commit forces to combat, and every assessment of what victory might require and cost. The hidden cost of war: transport, maintenance, and supply. Part 2. The transportation equation. Moving an army is among the most complex logistical challenges humans have ever attempted. Its scale defies intuition. The difficulties multiply with every mile. The costs compound exponentially as distance increases and terrain grows hostile. Transportation in war is not simply a matter of loading trucks and driving from point A to point B. It is an intricate mathematical puzzle where every variable affects every other, where solutions to one problem create new problems elsewhere, and where failure at any point can cascade into catastrophe. Every mile traveled multiplies the difficulty exponentially. This is not metaphorical, It is mathematical reality. Supplies must move faster than they are consumed, yet the very act of transportation consumes resources itself. Fuel trucks burn fuel to deliver fuel. Supply convoys require their own food, water, protection, and maintenance. The trucks themselves need spare parts, mechanics, and regular servicing. The drivers need rest, rotation, and medical support. Security forces must protect the convoys, which means more personnel requiring supplies. The equation spirals outward, creating overhead costs that can exceed the value of delivered supplies. Consider the stark arithmetic. A cargo truck traveling 300 miles to deliver supplies might consume 50 gallons of fuel making the journey. If that truck is carrying fuel, it delivers 50 gallons less than its capacity simply to reach its destination. If the round trip is 600 miles, the truck consumes 100 gallons, meaning a 500-gallon fuel truck delivers only 400 net. Now add the fuel consumed by escort vehicles, the fuel needed for generators at rest stops, the fuel required to transport the truck drivers' food and water, and the returns diminish further. Extend the supply line to 1,000 miles, and the percentage of useful delivery drops precipitously. At extreme distances, some convoys consume more resources than they deliver. This transportation paradox has shaped military history. The logistician's nightmare is a simple question. How do you supply the forces that supply the supply forces? The answer often determines whether campaigns succeed or fail. Ancient armies solved this through local foraging, living off the land they traversed. But this strategy had severe limitations. It required moving through populated, productive areas. It turned civilian populations into enemies. It slowed armies to walking pace. And it collapsed entirely in barren terrain or devastated war zones where nothing remained to forage. The industrial age promised solutions but delivered new complications. Railroads could move enormous quantities of supplies rapidly and efficiently, only where tracks existed. Railway networks became primary military targets. Armies had to protect hundreds of miles of vulnerable track, bridges, and stations. They needed to rebuild destroyed sections constantly. They faced the challenge of different track gauges between nations, requiring time-consuming transfers of cargo. During World War I, the German advance into Russia stalled partly because Russian railways used a different gauge than German ones, forcing the construction of transfer facilities and causing massive delays. The advent of motor transport promised liberation from railways' fixed routes. Trucks could go anywhere roads existed, and many places where they did not. The flexibility revolutionized military operations, but it came at enormous cost. Trucks were mechanically complex, prone to breakdown, and required constant maintenance. They consumed vast quantities of fuel. They needed spare parts manufactured to precise specifications. They demanded skilled drivers and mechanics. Road networks designed for light civilian traffic collapsed under the weight of military convoys. Bridges built for horse carts failed under loaded supply trucks. Unpaved roads became impassable quagmires in rain. During World War II, the Allied invasion of Normandy showcased both the potential and the problems of modern military transportation. The operation required moving 150,000 troops across the English Channel on the first day alone, followed by continuous resupply of a growing force that would eventually exceed 2 million soldiers. The Allies could not count on capturing ports intact. German forces would demolish harbor facilities before retreating. The solution was engineering on an almost unimaginable scale. The Allies constructed 2 artificial harbors codenamed Mulberry harbors that were towed across the Channel and assembled off the Norman coast. These temporary ports could handle 7,000 tons of vehicles and supplies daily. They included 23 floating piers, 10 miles of floating roadways, and 93 concrete caissons that served as breakwaters. The construction consumed 600,000 tons of concrete and steel. When a severe storm destroyed one Mulberry harbor just 2 weeks after D-Day, it threatened the entire campaign. The remaining harbor became a critical choke point, with vessels waiting days to unload, while armies inland ran short of ammunition and fuel. The Allies also constructed Operation Pluto, pipeline under the ocean, laying fuel pipelines on the Channel floor. By war's end, these pipelines delivered 1 million gallons of fuel daily, eliminating the need for thousands of vulnerable tanker truck trips. The engineering required was extraordinary, including the development of special flexible pipe, enormous floating spools to lay the pipe, and pumping stations disguised as innocent buildings on the English coast. Even with these innovations, transportation remained the binding constraint on Allied operations. As armies advanced inland from Normandy, they outran their supply lines. The port facilities, though impressive, could not keep pace with the consumption of rapidly advancing mechanized forces. The solution was the Red Ball Express, a convoy system that became legendary for its scope and desperation. The Red Ball Express operated 6,000 trucks continuously along designated routes marked with red ball symbols. These trucks, driven primarily by African American soldiers in segregated units, ran 24 hours a day in massive convoys. At peak operations, a truck left the Normandy beaches every 3 minutes, heading toward the front lines hundreds of miles away. The convoys stretched for miles, creating massive traffic jams, accidents, and coordination nightmares. Drivers pushed vehicles beyond safe limits, sometimes driving 20 hours straight to meet delivery deadlines. The system consumed nearly 300,000 gallons of fuel per day just to deliver fuel and supplies to the front, a staggering overhead cost. Mechanical breakdowns occurred constantly. Approximately 75% of the trucks required maintenance or repair during any given week. Tire wear was catastrophic, with trucks sometimes requiring new tires after just a few hundred miles on war-damaged roads. The Express operated for only 83 days, but in that time it delivered 412,000 tons of supplies at the cost of immense wear on vehicles, infrastructure, and personnel. Modern warfare has only intensified these demands. The fuel consumption of contemporary military equipment exceeds anything from previous eras. A single M1 Abrams tank travels approximately 0.6 miles per gallon, meaning it consumes nearly 2 gallons of fuel for every mile traveled. The tank's 500-gallon fuel capacity provides a combat range of only about 300 miles. An armored division with 150 tanks requires 75,000 gallons of fuel just to move those tanks 300 miles, without counting fuel for support vehicles, generators, and auxiliary equipment. Air operations multiply the fuel demands exponentially. An Apache attack helicopter consumes 140 gallons of fuel per hour of flight. A Chinook transport helicopter burns 300 gallons per hour. Fighter jets can consume thousands of gallons in a single sortie. An F-16 uses approximately 800 gallons per hour, while larger aircraft, like the B-52 bomber, can burn 3,300 gallons per hour. An aircraft wing conducting sustained operations can consume over 1 million gallons of jet fuel per week. Naval vessels represent floating cities with commensurate supply needs. An aircraft carrier requires 100,000 gallons of fuel daily for its own propulsion and operations, plus fuel for its aircraft. The ship's crew of 5,000 consumes tons of food, water, and supplies every day. Resupplying a carrier at sea, underway replenishment, is a complex ballet of synchronized ships moving at speed while transferring fuel, ammunition, food, and equipment via cables and helicopters. The support ships themselves require fuel, supplies, and periodic resupply, creating layers of logistical dependency. The logistics train extends thousands of miles from production facilities to frontline positions, creating vulnerabilities at every point along the chain. A spare part manufactured in Ohio must travel by truck to an airbase, fly across oceans to a theater distribution center, transfer to ground transport, move through multiple supply nodes, and finally reach a maintenance unit that installs it in a vehicle. The journey might take weeks. The part might be urgently needed within hours. The mismatch between supply timelines and operational needs creates constant crises. The cost extends far beyond fuel. Roads deteriorate under the weight of military traffic far faster than civilian use would damage them. A single passage of a heavy tank can destroy road surfaces designed for ordinary vehicles. Bridges require constant inspection and reinforcement. Railways need continuous maintenance as the volume and weight of military trains exceed design parameters. Ports need dredging and expansion to handle military vessels and cargo volumes. The infrastructure doesn't just support the war, it becomes a war into itself, requiring constant repair, expansion, and protection. Vehicles break down at accelerating rates under combat conditions. Civilian vehicles might require major maintenance every 50,000 miles. Military vehicles operating in combat zones might need major service every 5,000 miles. For every hour a military vehicle operates in harsh environments, it may require 5 hours of maintenance. In desert conditions, the ratio becomes even worse. Sand infiltrates every component, abrading moving parts and clogging filters. Heat causes seals to fail and fluids to break down. The maintenance burden becomes overwhelming. Enemy action transforms transportation from difficult to potentially suicidal. Convoys become targets. Roads are mined. Bridges are destroyed. Ambushes devastate supply columns. The need for security diverts combat forces to convoy protection. During operations in Iraq and Afghanistan, insurgents recognized that attacking supply convoys was tactically easier and strategically more damaging than attacking fortified bases. Improvised explosive devices targeted fuel trucks, creating spectacular explosions and disrupting supply flows. The U.S. military calculated that one soldier or Marine was killed or wounded for every 24 fuel resupply convoys in Afghanistan. This vulnerability drove desperate innovations. The military invested billions in heavily armored supply vehicles that could survive IED attacks, but these vehicles consumed even more fuel and required even more maintenance. Alternative fuels were explored, including biofuels that could potentially be produced in theater, reducing dependence on vulnerable supply lines. Forward operating bases installed solar panels and wind turbines to reduce diesel consumption for generators. Every innovation added complexity and cost. The transportation equation ultimately cannot be solved, only managed through constant effort, enormous expense, and acceptance of risk. Moving armies remains one of the most resource-intensive activities humans undertake. The costs compound at every level. The vulnerabilities multiply with every mile, and the demand for resources grows faster than the ability to supply them. Understanding this equation is essential to understanding modern war itself. The hidden cost of war: transport, maintenance, and supply. Part 3. Maintenance, the endless battle. While politicians and generals focus on procurement, the billions spent on new weapon systems, advanced aircraft, and cutting-edge technology, the real financial hemorrhage occurs in maintenance. The acquisition cost of military equipment represents merely the down payment on a decades-long obligation. A fighter jet may cost $100 million to purchase, but over its operational lifetime of 30 years, maintenance and support can exceed $400 million. For every dollar spent buying a weapon system, 4 or 5 more will be spent keeping it operational. This ratio holds across nearly all military equipment, creating cost structures that dwarf initial procurement budgets and trap defense planners in endless cycles of maintenance expenditure. The disparity between purchase price and lifetime cost reflects a fundamental reality of military equipment. It is designed for performance, not maintainability. Civilian vehicles are engineered for reliability, ease of repair, and long service intervals. Military equipment is engineered to survive combat, deliver maximum performance, and incorporate the latest technology, considerations that often conflict directly with ease of maintenance. The result is equipment that is extraordinarily capable and extraordinarily expensive to keep running. Military equipment operates under conditions that would destroy civilian machinery in days. These are not exaggerations, but documented realities from conflict zones worldwide. Tanks drive through dust, mud, and debris that infiltrates every component, despite extensive sealing and filtration systems. They crash through obstacles that would total ordinary vehicles. They absorb battle damage from small arms fire, shrapnel, and occasionally direct hits from anti-tank weapons. Even non-penetrating hits create shock waves that damage internal components, requiring extensive inspection and repair. Naval vessels endure corrosive salt water that attacks every exposed surface. The marine environment is uniquely hostile to machinery. Salt spray corrodes electronics, degrades paint and protective coatings, and penetrates seals to damage internal mechanisms. The constant motion of ships at sea creates vibration and stress that fatigues metal and loosens connections. Temperature variations from freezing spray on deck to engine room heat exceeding 120 degrees Fahrenheit stress materials and cause expansion and contraction that accelerates wear. Aircraft experience perhaps the most demanding operational environment. They endure extreme temperatures ranging from -60 degrees Fahrenheit at altitude to over 100 degrees on desert tarmacs. They experience G-forces during combat maneuvers that stress airframes and components beyond anything civilian aircraft encounter. They land on carrier decks at controlled crash velocities that would destroy commercial aircraft. Military helicopters operate in brownout conditions where rotor downwash creates clouds of sand and debris that sandblast components and infiltrate engines. The maintenance required after such operations is constant, expensive, and absolutely critical to preventing catastrophic failures. The U.S. military discovered this reality painfully during the wars in Iraq and Afghanistan. Desert conditions caused equipment to fail at 3 to 6 times the normal rate predicted by peacetime maintenance schedules. Fine sand with particles smaller than talcum powder penetrated engine seals designed to keep out water and larger debris.
This sand acted as an abrasive compound, grinding down moving parts, clogging oil passages, and destroying bearings. Filters that normally required changing every few hundred hours needed replacement every few dozen hours. Some equipment required filter changes after every mission. The cost of maintaining equipment in theater often exceeded the cost of the operations themselves. A helicopter that might normally require 10 hours of maintenance for each flight hour required 20 or 30 hours in desert conditions. Mechanics worked around the clock in temperatures exceeding 120 degrees, often under basic tent shelter with inadequate lighting and primitive facilities.
The supply system struggled to provide sufficient spare parts as consumption rates exceeded all projections. Critical components went on backorder, grounding aircraft and vehicles that were mechanically repairable but lacked a single failed part. The Army's experience with Bradley fighting vehicles in Iraq illustrates the maintenance burden starkly. Under normal peacetime conditions, Bradleys required approximately 6 hours of maintenance per operating hour. In Iraq, that ratio increased to 15 hours of maintenance per operating hour. The vehicles consumed final drives, complex gear assemblies in the track system at 10 times the predicted rate. Each final drive cost approximately $50,000 and required 40 hours of skilled labor to replace. Multiply that across hundreds of vehicles, and the maintenance costs became astronomical. But maintenance extends far beyond mechanical repair. Military operations consume and degrade equipment and supplies across every category of material. Ammunition must be inspected and rotated to prevent deterioration. Artillery shells have shelf lives measured in years or decades, but those lifespans assume controlled storage conditions. Ammunition stored in field conditions, exposed to temperature extremes and humidity, degrades faster and must be inspected more frequently. Munitions that fail inspection must be demilitarized and disposed of, an expensive and dangerous process. Electronic systems require constant calibration and updating. Modern military operations depend on networks of communications equipment, radar systems, electronic warfare suites, and computer systems. These technologies advance rapidly, requiring frequent software updates, hardware upgrades, and replacement of obsolescent systems. A radio system purchased 5 years ago may be technically functional, but incompatible with newer equipment, forcing upgrades or replacement to maintain interoperability. The obsolescence cycle for electronics is measured in years, not decades, creating relentless pressure to update and modernize. Communications equipment needs continuous maintenance to ensure reliability in combat. Radio systems must be tested, antennas inspected, encryption systems updated, and batteries maintained. Satellite communications equipment requires precise alignment and regular recalibration. Cybersecurity demands constant vigilance, with software patches and security updates applied continuously to prevent hostile penetration of military networks. The maintenance burden for these systems is largely invisible but absolutely essential. Body armor degrades and must be replaced on strict schedules. Kevlar and ceramic plate armor have finite lifespans, beyond which they cannot be certified to provide advertised protection. Exposure to sunlight, moisture, and physical stress accelerates degradation. Armor that has stopped bullets or shrapnel must be replaced even if it appears intact, as internal damage may compromise future protection. The logistics of tracking armor service life, testing for degradation, and replacing expired equipment across hundreds of thousands of personnel represents a massive administrative and financial burden. Medical supplies expire and require constant rotation.
Combat operations require extensive stockpiles of medical supplies positioned at multiple echelons, from individual first aid kits to combat support hospitals. Many pharmaceuticals have shelf lives measured in months or years and must be used or discarded before expiration. Blood products for transfusion last days or weeks at most. Saline solutions, antibiotics, pain medications, and countless other medical necessities must be continuously monitored, rotated, and replaced. The cost of maintaining adequate medical supply stockpiles represents a significant portion of overall logistics budgets. Every item in a military's inventory demands ongoing attention, creating a permanent workforce of mechanics, technicians, and specialists whose labor rarely appears in war's visible narrative. These personnel represent a hidden cost that compounds over time. A mechanic requires training, housing, feeding, equipping, and paying. They need tools, diagnostic equipment, technical manuals, and parts. They require supervision, administration, and support services. The overhead costs associated with maintenance personnel can equal or exceed the direct costs of the parts and materials they use. The human cost of maintenance is equally hidden but profound. Maintenance personnel work around the clock in dangerous conditions, often under fire. During the 2003 invasion of Iraq, maintenance units traveled with combat formations, repairing battle-damaged vehicles while fighting continued around them. Mechanics worked on vehicles that had just been hit by rocket-propelled grenades, knowing another attack could come at any moment. The psychological stress of working under combat conditions while performing technically demanding tasks created mental health challenges that persist long after deployments end. They suffer from exhaustion as operational tempo forces extended work schedules. 12-hour shifts become 16-hour shifts, become working until the job is done regardless of time. Sleep deprivation impairs judgment and increases accident rates. Maintenance personnel suffer injuries from heavy equipment, burns from hot components, cuts from sharp metal, and exposure to toxic substances like hydraulic fluid, lubricants, and battery acid. Some injuries are minor, cuts and bruises that come with the work. Others are severe or permanently disabling. The work creates constant pressure, knowing that their work determines whether fellow soldiers live or die. A mechanic who signs off on a helicopter repair knows that aircraft will carry troops into combat. An improperly secured component, a missed crack in structural members, a hurried inspection that overlooks damage, any of these could lead to catastrophic failure and deaths. The responsibility weighs heavily. Maintenance personnel frequently report stress levels comparable to combat troops, though their contributions are rarely recognized with equivalent valor awards or public acknowledgement. A poorly maintained vehicle can be as deadly as enemy fire. History is filled with casualties from maintenance failures. Helicopters have crashed from improperly installed components. Tanks have exploded from fuel leaks igniting on hot exhaust systems. Aircraft have disintegrated in flight from undetected metal fatigue. Weapons have malfunctioned at critical moments. While some failures are unavoidable, random mechanical failures that occurred despite perfect maintenance, others result from impossible maintenance schedules, inadequate parts supply, insufficient time for proper procedures, or exhausted technicians working beyond the limits of human endurance. The maintenance burden creates strategic constraints that limit operational options. Military planners must factor maintenance timelines into every decision. An air campaign cannot sustain maximum sortie rates indefinitely because aircraft require scheduled maintenance at specific flight hour intervals. Ground offensives must pause periodically to allow maintenance units to catch up with repairs. Naval operations must route ships through ports where maintenance facilities exist. These constraints shape strategy as much as enemy action does. The financial implications extend decades into the future. Equipment purchased today creates maintenance obligations that last 30, 40, or 50 years. As equipment ages, maintenance costs typically increase, while reliability decreases. Older systems require more frequent repairs, longer downtimes, and increasingly expensive parts as manufacturers discontinue production. Eventually, maintenance costs become unsustainable, forcing replacement, which begins the cycle anew. Modern militaries now confront the reality that maintenance, unglamorous, technically complex, and maddeningly expensive, represents the true cost of military power. The fighter jets, tanks, and ships that project strength on parade grounds require armies of maintainers working in obscurity to keep them functional. Without these invisible workers and the vast infrastructure supporting them, the most sophisticated military equipment becomes inert metal, incapable of fulfilling any mission whatsoever. Understanding this reality transforms how we calculate the cost of military capability and the true burden of sustaining armed forces capable of modern warfare.
The hidden cost of war, transport, maintenance, and supply. Part 4. The strategic calculus. Understanding the hidden costs of war transforms how we evaluate military strategy and national security. The most brilliant tactical plan becomes meaningless if the logistics cannot support it. The most advanced weapons serve no purpose if they cannot be maintained in the field. The largest army in the world is helpless if it cannot be fed, fueled, and supplied. This fundamental truth has shaped the outcome of conflicts throughout history, yet it remains poorly understood by publics, politicians, and even some military leaders who focus on the visible drama of combat rather than the invisible mechanics of sustainment. History's greatest military minds understood this reality with exceptional clarity. Eisenhower, who commanded the largest amphibious invasion in history and coordinated Allied operations across multiple theaters, famously stated that battles, campaigns, and even wars have been won or lost primarily because of logistics. His experience planning D-Day drove home the lesson that tactical brilliance matters little when soldiers lack ammunition, vehicles lack fuel, or wounded lack medical care. Eisenhower spent more time in planning meetings discussing port capacity, fuel pipelines, and supply routes than discussing tactical tactics. He understood that logistics was not a supporting function, but the foundation upon which all military operations rested. Alexander the Great, perhaps history's most celebrated conqueror, built his empire on logistical innovations as much as tactical genius. He revolutionized military supply by reducing the baggage train that slowed ancient armies to a crawl. He trained his soldiers to carry more of their own equipment, established supply depots along routes of advance, and coordinated with local allies to provide food and fodder. His army could march faster and farther than any contemporary force precisely because he solved logistical challenges his opponents ignored. When Alexander's successors failed to maintain these logistical systems, their military effectiveness collapsed despite commanding the same soldiers and using the same tactics. The German Wehrmacht's failure in the Soviet Union stemmed not from lack of courage or tactical skill, but from supply lines stretched beyond sustainability. German planning for Operation Barbarossa,
the 1941 invasion of the Soviet Union, assumed a short campaign culminating in Soviet collapse within weeks or months. The logistics plan reflected this assumption. Germany's truck fleet was inadequate for the vast distances involved and included hundreds of different vehicle models requiring different spare parts, creating maintenance nightmares. The railway system depended on converting Soviet broad gauge tracks to European standard gauge, a process that proceeded far slower than anticipated. As the invasion stalled and winter approached, the logistical system collapsed. The Luftwaffe had aircraft capable of flying, it lacked fuel to operate them. Ground forces had tanks mechanically functional, they lacked fuel to move them. German soldiers froze in summer uniforms because winter clothing sat in warehouses hundreds of miles behind the front, unreachable due to transportation breakdowns. Horses, the Wehrmacht still relied on over 600,000 horses for logistics, died by the thousands from overwork, inadequate fodder, and cold. Without horses to move supplies, even materials that reached railheads could not reach frontline units. The strategic consequences proved catastrophic. German forces came within miles of Moscow in December 1941, but could not deliver the final blow because soldiers lacked ammunition, fuel, food, and winter equipment. The Red Army, fighting on interior lines with shorter supply routes, counterattacked and drove German forces back. The Wehrmacht would never again threaten Moscow. The failure was fundamentally logistical. German tactical and operational excellence could not overcome the mathematics of distance, consumption, and supply capacity. Modern militaries now spend between 50 and 60% of their operational budgets on logistics and maintenance, costs that escalate dramatically during conflict. In peacetime, this percentage seems shocking to those unfamiliar with military operations. Politicians question why so much money goes to support functions rather than combat capabilities. The answer is that without the support functions, combat capabilities do not exist. A fighter jet without fuel is sculpture. A tank without ammunition is a bunker. An army without food is a mob. The support functions are not overhead. They are the operational capability itself. The wars in Iraq and Afghanistan demonstrated these costs with brutal clarity. The conflicts cost the United States trillions of dollars when accounting for all expenses, including long-term veteran care and interest on borrowed money. A substantial portion was consumed by logistics, supply convoys, equipment repair, and the infrastructure required to maintain operations thousands of miles from home bases. The U.S. military constructed hundreds of forward operating bases, each requiring constant supply of fuel, water, food, ammunition, and construction materials. Some bases in Afghanistan could only be supplied by air at costs exceeding $400 per gallon of fuel delivered, not because the fuel itself was expensive, but because the transportation cost was astronomical. These hidden costs have profound implications for how nations approach conflict. The economic burden of sustained military operations often exceeds the political will to continue them. Wars that begin with public enthusiasm and congressional support become politically unsustainable as the costs mount. The American public's support for the Afghanistan war eroded over 2 decades, partly because the financial burden, estimated at over $2 trillion, seemed disproportionate to achievable outcomes. Much of that cost was logistical, moving, supplying, and maintaining forces in one of the world's most logistically challenging environments. The tooth-to-tail ratio, combat troops versus support personnel, has grown increasingly top-heavy as warfare has become more technological and logistically complex. In World War II, the U.S. military maintained approximately one support soldier for every combat soldier. By the Vietnam War, the ratio had shifted to 3 support personnel for every combat soldier.
In Iraq and Afghanistan, some estimates suggested the ratio reached 10 support personnel for every combat soldier, including contractors performing logistics functions. This ratio shocks those unfamiliar with modern warfare, but it reflects inescapable reality. A single infantry company of 120 soldiers requires extensive support, mechanics to maintain vehicles, supply specialists to order and distribute equipment, communications technicians to maintain radios and networks, medics and medical facilities, cooks to prepare food, administrative personnel to handle pay and personnel issues, intelligence analysts to provide threat information, and countless other specialists. Multiply this across brigade, division, and corps levels, and the support structure dwarfs the combat force it sustains. Some critics argue this represents wasteful bureaucracy and advocate for leaner forces with higher ratios of combat to support troops. This argument misunderstands modern warfare. The extensive support structure exists because modern combat operations demand it. Soldiers cannot fight effectively while also performing vehicle maintenance, managing supply inventories, treating casualties, and handling administrative tasks. Specialization increases effectiveness but requires more personnel. Technology increases combat power but requires more maintenance. The tooth-to-tail ratio reflects not bureaucratic excess but operational necessity. Perhaps most importantly, recognizing these costs should inform decisions about when and how to go to war. The visible price of conflict, the bombs dropped, the battles fought, the soldiers deployed, represents only a fraction of the true expenditure. A bomb that costs $50,000 requires a $100 million aircraft to deliver it, requires thousands of gallons of fuel to fly the mission, requires maintenance personnel to prepare the aircraft, requires logistics personnel to deliver the bomb to the airbase, requires intelligence personnel to identify the target, and requires support infrastructure spanning the globe. The full cost of that single bomb might exceed $1 million when all supporting costs are included. The hidden costs of war continue long after the fighting stops, creating financial obligations that burden nations for decades. Equipment must be repaired after intensive combat use, often requiring complete rebuilds. Vehicles, aircraft, and ships return from deployment requiring maintenance that costs millions of dollars per unit. Equipment damaged beyond repair must be replaced. Ammunition stocks depleted during combat must be replenished. Infrastructure constructed for the war, bases, ports, roads, communications networks must be maintained, dismantled, or transferred to host nations. The human costs extend even further. Veterans require medical care for injuries and illnesses incurred during service, creating obligations lasting decades. The U.S. is still paying disability benefits to dependents of veterans from World War II. The total cost of caring for Iraq and Afghanistan veterans will not be known for decades, but will certainly exceed $1 trillion. These costs are legitimate obligations to those who served, but they are costs nonetheless, and they must be factored in to any honest accounting of what wars cost. These costs compound over time in ways that are difficult to predict and impossible to avoid.
Interest on money borrowed to finance wars adds hundreds of billions of dollars to the ultimate cost. Economic disruption from deploying large portions of the workforce to military service reduces economic productivity. Resources devoted to military operations cannot be invested in infrastructure, education, research, or other productive uses. The opportunity costs, the benefits society forgoes by choosing war, may exceed the direct costs. Understanding the full cost of war should inject humility into decisions about military intervention. Leaders contemplating war should understand they are committing not just to the visible costs of combat operations, but to decades of hidden costs for logistics, maintenance, and support. They are accepting obligations that will burden budgets for generations. They are making decisions whose full financial implications will not be known for decades.
This does not mean war is never justified or necessary. Genuine threats to national security sometimes require military response, regardless of cost. But the decision should be made with clear understanding of what it entails. War is not simply about deploying forces and fighting battles. It is about sustaining complex logistics networks, maintaining vast fleets of equipment, and supporting millions of personnel through decades of consequences stemming from months or years of combat. The hidden cost of war is not merely financial, though the financial burden is staggering. It represents the vast human effort required to sustain violence across distances and time. It encompasses the mechanics who work through the night, the truck drivers who navigate hostile roads, the supply officers who calculate impossible equations, the medical personnel who treat endless casualties, the logistics planners who coordinate movements of millions of tons of material, and the countless others whose labor make war possible. Their work is invisible to history's cameras, absent from news coverage, and omitted from most histories, but it is the foundation upon which all military operations rest. Understanding this reality doesn't just change how we count the cost of war, it changes how we decide whether that cost is worth paying. It injects necessary realism into strategic planning, forces honest accounting of what military operations truly require, and ensures that decisions about war are made with full knowledge of their implications. The hidden costs of war remain hidden only to those who choose not to look. For those willing to examine the full picture, the costs are staggering, sobering, and impossible to ignore. Only by understanding these costs can societies make informed decisions about when war serves national interests and when its burden exceeds any achievable benefit.